Okay. So, quiet, please. Okay. It's not going to take that long before I get started on doing another worksheet. Actually, I noticed on PBS they're going to have a show 9 o'clock on Wednesday, which is actually about this book, which I mentioned actually before the break. But this book is specifically about are things like, let's say, the Pythagorean theorem, which we all know means in a right triangle you go a squared plus b squared equals c squared. Is that as real as the desk? Is it a thing that's like out there, a truth which is out there for us to know, just like the fact of all of us sitting here right now? Or is it something that man invented? Right? Did we invent that relationship? Or is it like a relationship that existed and we just discovered it? Which one is it? That we discovered it, right? Probably where most mathematicians would think is, at least at the beginning, is that it's more we're discovering truths that are out there. They're as true as, our existence right here. And if they are truths and we just discover them, then God is a mathematician. If we're inventing them, then he's not. And that's what the book is about. And that, I thought it was kind of ironic, but there's going to be a show on PBS 9 o'clock which talks about that thing. My guess is that the author here will be on the show because that's all this book is about. Okay. I didn't expect, maybe you could do a book report on it or something. But in this book, right, and this guy's like tracing the history of the thought of mathematics as whether or not it's been invented or discovered and all that. He makes this statement here, which is, when the guy introduces the coordinate plane, right, which we're all familiar with plotting points in the coordinate plane, where you have a horizontal axis, which we label with the X on it, right? And there is a vertical axis, which we label as the Y. And then any particular point in the coordinate plane we use for an ordered pair, where the first number is the X and the second is the Y, right? It's an address that directs you to a point somewhere in this plane, right? So if I said, for example, 1, 4, then I would know that I would go in the X direction, positive 1, and in the Y direction, positive 4. And there's the point right there, 1, 4. Now, before the guy who did this came along, we knew things already, like, a circle is the set of all points which are the same distance from a middle point, right? I mean, that's more or less what we would think of as geometry, right? This guy came along and said, no, once we come up with this kind of a construct, then we can actually come up with an equation that describes a circle. And the equation looks something like this, right? X squared plus y squared equals r squared. So basically, this guy, his name is Descartes, came along in the 1600s. He's a French guy. And him, by inventing this thing, is able to turn all of those geometrical things into what they call analytic geometry, basically equations, functions that we can study. And according to this guy here, that this is the greatest single step ever made in the progress of the exact sciences. This one thing. I mean, it really, really made a difference in the progress if you look over time and what things were able to come after that. Because what could we do after that? Devin, okay, don't talk, okay? Okay. I mean, then it's only after this we could start to talk about what we call functions, right? Functions can be linear, they can be quadratic, they can be circles, they can be all kinds of things, right? So this was a really big deal. And so how you plot points in the coordinate plane, which is our next step, because after that we're going to talk about linear functions, we need a review on that concept too, because I'm sure, make some mistakes in this too. So this is the concept, right? The coordinate plane, right? The first number is going to tell you where to go in the X direction, horizontal. If it's positive, you go to the right. If it's negative, you go to the left. The second number will tell you how much you're going to go up or down, right? If it's positive, you go up. If it's negative, you go down, right? So let's stop that there. I'm going to give you a worksheet, which is an exercise in plotting these points. Not that. So here we go. Plot the points that are at the top of the page. Each one of them has a letter. Right? So at that point, make a dot and then label it with the letter. Okay. So I would think it would take us 5 minutes, maybe 10. You can, no, not at this point, but there's going to be homework that's connect the dots. Okay. So you should look up here and see pretty close. If there's something that doesn't look like it's in the right place, I mean, check. Maybe I'm wrong. You go fast, sometimes you're meant to go left, you're meant to go down, and you went left, something like that. When I lived in a town called Logan, Utah, years ago, right? And these towns, they were made, yeah. Which one? L. 5, 9. 1, 2, 3, 4, 5, 9. Oh, O is wrong. O should have been -4, +9. Oh, so O should have been up here. That is O. And then O, my mistake is there. Like I said, could have made a mistake. Anyways, when I lived in Logan, Utah was a city because a lot of these towns in the West, they were designed like in the 1800s. I mean, it's different out here in the East where a lot of these things go back, hundreds of years. And they have a lot of like irregularly shaped streets and maybe kind of narrow and that. Out there, they were able to program their cities to be very rectangular. And all of the addresses work like this. In almost all these towns in a place like Utah, always the main east-west town street in the town is called Center Street. The main north-south road is called Main Street. Okay, if you go to the addresses all work like this: 400 east, 600 north. That was your address, right? Which made it great in those days before GPS and all that. If you had to go hook up your phone service and you knew that the phone company was at 200 north and 300 west, okay, that means it was right there. You knew exactly where to go. I mean, my address when I lived there was 135 west, 800 north. So where did I live? Go up 8 blocks, and then 135 would be in between 1 and 2 to the west. So I lived about right there in the town. So, just using a grid, it works. Okay, so once we understand the concept of, we can actually have a coordinate plane, and every point in the plane has coordinates, an X and a Y. These are actually called Cartesian coordinates after the guy who invented it, Descartes, right? And then we come up with the idea of functions, which is now I can make graphs of things that are basically things that we're looking at in the coordinate plane and try to make sense out of them. And the first lesson that this has is about not any particular kind of a shape of a graph, but just the concept of how is it that you put some physical process on a graph. Like this one is blowing up a balloon until it pops, right? So at the beginning, you've got an empty balloon, so it has no volume. And then you start to blow it up. And what happens? It gets bigger and bigger, and then why do you think it stopped here? You probably stopped and took a breath. So that took a little bit of time. And then you kept blowing here, right? And then you stopped and you took another breath. And then you kept going and you stopped and took another breath. And then finally, what looks like it happened? It popped, right? You got up to a certain volume, and then the balloon popped, and so the volume went to zero all at once, right? So that's the graph of blown. And the way you usually say this in terms of, you say this is the volume as a function of time, right? Volume, the variables are volume of the balloon and the time you took to blow it up, right? Variables. Okay, volume and time. And this is volume as a function of time. So this is cell phone cost in a month. And you could see that there's a flat line, which, what does it mean if the cost is a flat line from here until a certain number of minutes of calls, and then it goes up from there? What kind of a plan do you got? Yeah, it's not unlimited, which is, I think this is a little dated because how many people don't have unlimited calls these days? I mean, it's almost like automatic, right? But in those days, and you might remember those days, that you got a certain number of calls for the same price. And then after that, the price went up, right? So what are the variables here? The cost, and it's cost as a function of your number of minutes, right? Cost as a function of minutes. Now, here's some data. It might be kind of hard for you to see here, but this is 346, 1011, 3455, and 10,426. And this is 1, 2, 3, and 4. Which one of these graphs looks like it probably represents those 4 points that have been graphed? A. Now, what is the shape of this? That would be linear. That looks like it could be a straight line. So if it was linear like that, then you would expect that if, for example, at 4 it was 10,000, right? Then it should be half of that at 2. Okay, what is it at 2? It's not half of 10,000, it's a tenth. So this is not a linear relationship. Okay, so let's see. Is it possible that it's D? That they're going down? No, they're clearly going up. Okay, so that means it's either this one or this one. Okay, so this one has it going up very fast at the beginning and then kind of leveling off. This one has it going up slowly and then going up really quickly. So which one does it look like here? Probably the B, right? B. See, and this is just general. They didn't actually label any of these points here, right? The axis is not labeled, so you could like match it up with numbers. Yeah. Yes. Okay, how about this one? This is the amount of sunscreen and the number of uses. So how much do you put on based on the number of uses, I guess? So the number of uses is on this axis and the amount of sunscreen is here. You could definitely see the number of uses goes from 0, 1, 2, 3. 0, 1, 2, 3. Which one of these looks like it represents that data? Well, let's see. All three of them look like the numbers are going down and the numbers are going down. Okay, why couldn't it be this one? Yeah, it hit 0 and this never hit 0. Okay, why not this one? Yeah, it looks like it's decreased too much, right? This only goes from 5 to 4.4. If that was 5, what do you think that number would have been? It would have been like 1. So the answer should have been that right there. Okay, and then, you know, this is one. There's going to be the last homework problem is like try to just sketch a graph that describes, you know, whatever it is that's in the homework problem. You know, this one is the height of a model rocket that's being sent up into the air as a function of what? height of the rocket as a function of time, right, of the horizontal axis right there. So what does it look like it's going on? You know, here the height is 0. So what's happening in between here and here? The rocket is being shot up into the air, right? Okay. And then what does this represent right there? At some point, it stops going up. So the graph has to level off. And then what is it doing there? It starts to fall. And then this one is because the parachute came out. So it was going down kind of quickly. In fact, if you were going to have a graph like this in the real world and it had no parachute involved, this would be a parabola. And you would see it going down as fast as it went up. That stopped it because of the balloon. Now it just kind of gradually floated to the ground. And so the homework is, in the workbook, page 111, there's 1 through 6 are like the first couple things we did. The 11 is, you know, just sketch a graph according to what is being described. See if you can come up with something. The other one, which is what I said, there is going to be a plotting of points thing, is going to be this, okay? I'm going to give you a blank coordinate plane. And I want you to draw a picture that goes from, keep it clean, Devin, okay? And then just write down the points, right? And then in class tomorrow or the next class, then you're going to just give those points to somebody else and see if they can come up with your sketch, okay? So you might want to like put them in an order. If it's going to be like connect the dots and you want to like make sure you plot them in order. But the first order of business is sketch something. I mean, you could sketch the capital letter of your first name or something like that. You know, big block letters or something like that. You know, come up with a picture, sketch it, and then come up with the vertices, the corner points. And those are going to be what you're going to hand to somebody else with another blank one. And then they're going to redo your whatever it is. Okay? Isn't that fun? Three, four. Choppa. Maybe they're going to end up adding another 15 minutes. No, I think we need more time. Yeah, I think we definitely need more time and less control on our thermostat. Okay. And that is over.